So
So you will switch off a camera, is it correct? That you would like to not be with the camera, right?
I can be with camera if you
Yeah, that's yeah, just
if you allow
more
me to
kind
do
of human.
this.
If we can see you and observe you. All right.
Okay. So the purpose of this work is to start study the potential possibilities of detecting UAVs in any weather and tactical conditions of uh, conducting measurements due to the use a radiometric complex operating in several wave ranges. In recent years, the scope and number of applications of various types of UAV has expanded significantly. Their influence cannot be ignored already, and their use will only expand in the future. The main threats from UAVs are their unauthorized use in cities, airports, and uh, critical infrastructure facilities, which can be endangers the lives of many people. Detection systems are based on various types, namely radiotechnical, optical, infrared, thermal imaging, and acoustic systems. For example, optical systems are best used during the day in clear weather. As soon as the conditions change, such as the onset of nights or cloudy weather or rain, it is advisable to supplement these types of systems with infrared or thermal imaging means, which at the same time also have their limitations. For example, for thermal imaging methods, the detection, the fact that the motors of UAV may not heat up so much that is always visible, and for the infrared again, unfavorable weather conditions can be. The acoustic methods require the installations of large number of receiving sensors along the flight path of the UAV. And also, active radar detection system has the greatest detection range. They also have a blind zone and can be less effective in detecting small objects. And also, new composite materials from which UAV are made can be specifically designed to reduce visibility for some wavelengths for active radar. And the main disadvantage is visibility when the radar is turned on. Each of the methods has its advantages and disadvantages, but they are united by the fact that in the same time, the research is being conducted to the development, the methods and applications for reducing the visibility of UAV in the specific ranges. Therefore, it is proposed to use a passive radar system for detection. A passive radar receiving signals using radiometers. Such systems are hidden, ultra-sensitive, and capable of registering the radiothermal radiation of aircraft, including those which made of composite materials in wide spectrum of frequencies against the background of the atmospheric radiation in any weather at day and in the night. During the period of work at the department, a number of fundamental research were conducted using the unique equipment. Full-scale UAV detection experiments were conducted on the radiometric measurements platform of the National Aerospace University Kharkiv Aviation Institute, which made it possible to create a database of theoretical calculations and determinations of potential capabilities to detect the UAV. At the same time, the measurements were carried out with the help of receiving devices with a high sensitivity of no worse than 0.1 Kelvin, and the sensitivity of radiometer in the 3 mm range reached a unique value for Ukraine and advanced in the world level. The detection of radiothermal radiation signals is based on two hypotheses: the presence of noise signal at the input of the receiver and its absence. Brightness temperature of UAV suspended against the background of the sky was determined by the results of measuring the antenna temperature of present UAV or antenna temperature of the sky in its absence, taking into account the filling factor of radiation pattern of the horn antenna by target in the controlled range. One of the measured UAV shown as an example. Frequency dependence of contrast for UAV made of composite fiberglass material for the clear sky and the vertical polarization are given. Here the width of this show the receive band of each radiometer. The resulting contrasts were used to test and calculate the potential capabilities of the system. Calculations of the ranges of correct detection were carried out by depending on the area of UAV under different weather conditions. The figure shows generalized UAV detection range values with the probability of 0.9 for clear weather with a false alarm possibility of 0.01. And the figure shows, next figure shows the generalized UAV detection range values with probability 0.9 for cloudy weather with the same false alarm probability. The dashed line of the corresponding color is show cloudy weather. It can be seen that in all ranges, the influence of weather does not significantly affect the detection range. However, there is a significant influence in 3 mm range, and this is expected. And also the preliminary results are presented in tabular form. And this one is for rainy weather. We can see that 3 mm radiometer also show us bad range of detection. From the analysis of all these obtained results, it follows that for clear atmosphere, the radiometric receiver in the frequency range 35-36 GHz has the best indicators of detection probability. Changes in weather conditions have almost no effect for detection range in 10 and 12 GHz and for 20-22 GHz bands. The worst results can be observed for the frequency range of 94-96 GHz. At the same time, this receiver has the best spatial resolution, which improves the performance of the entire system and the stage of forming images for observation area. Considering the experimental results, the detection range were calculated with the probability 0.9 using components of domestic companies. The results show that depending on the state of the atmosphere, the detection range between 1 and 3 km. The results match the known detection ranges of optical, acoustic, and radar system, but the selector parameters of the receivers do not meet the potential world achievements and can be improved. Considering the results of the development of microwave components in the companies with world name, namely Pasternak Company, Millimeter Microwave, and etc., UAV detection limits were obtained. Such a multi-frequency radiometric complex can detect light UAV at the range of 6 to 8 kilometers. As a continuation of this topic, our research and experiments are now aimed at measurements with the addition of an active noise signal to eliminate the target. That's all. Thank you for your attention.
Okay, thank you for your report.
So, all right, thank you. Hlip, it was short, precise. Anybody, if you have questions about these ranges?
Okay, then maybe I can start the first question.
Okay.
Dear Gleb, we work at the same department, but I didn't mention some results before. Can you show the slide 8? You can see that the best results is given here by the radiometric sensor of 35-36 gigahertz. And show please the next slide. And here also the radiometer 35-36 gigahertz, it gives the best result. Can you explain why 8 millimeter range radiometric system gives the best results?
Mostly because of wavelengths and also because of whether window at this range for these wavelengths, and this radiometer was built, maybe I can say good, and meets the world level components. Also, you can see that in the rainy weather, this this radiometer show worse results, also because of specific of the wavelengths, because in the rainy the wavelengths of our radiometer and atmospheric droplets are maybe mostly in the same physical range, ranges.
Okay, thank you. I don't have questions.
All right, so we can go ahead, right?
Thank you.
Yeah, is it correct? So